Hello, my beautiful computer science students. Welcome to another lesson in Unit 2, Selection and Iteration. This is going to be Lesson 4, where we are working with while loops. If you're new here, I'm Goldie, and I'm here to take you through everything in the AP CSA course. Now, in this lesson, we are going to be learning and introducing while loops, learning about them, and just getting used to them, tracing through them, seeing what they do, and start to talk about how they are going to be helpful in our program. So grab your notes, get settled in, and let's get started in this lesson together. So when we talk about iteration is the process of repeating the same set of instructions while a condition evaluates to true. Now this is for specifically Java. We want to repeat some instructions while some sort of condition evaluates to true. So when we talk about iteration, we're talking about repeating a set of instructions. There are 3 loops in Java that we use to repeat a set of instructions. They're the for loop, the while loop, and the do while loop. And in AP CSA, we are only going to cover the while and the for loop. The do while is very similar to the while loop, but just a different syntax set of instructions. And we don't cover that in this course anymore. So there are just 2 iterations that you have to know as an AP CSA student. And today we're going to talk about the while loop. Now the while loop keeps executing its block of statements while a condition evaluates to true. And I say that to try to put some, regular English to it, right? While this condition is true, we're going to keep doing this, okay? So a while loop condition is checked first, and if it's true, the loop is then entered and the code is executed. And then once the end of that block is reached, so a while loop is you're going to see the block of statements. Once the end of that is reached, the program loops back up to the condition again and checks it. And if that condition is still true, the code segment goes through again, and the process is repeated inside the block. If it is false, then the loop ends and the loop is not executed again. So here's a very simple example of what you might see. So you start off with a declaration assignment here, int x equals 1, and then you see that while loop syntax. So it actually has the word while in it. There may or may not be a space here. That's up to you. And then we have our condition in parentheses, very similar to an if statement, right? An if statement had if, and then in parentheses, we had a condition. Same thing here. We have some sort of condition, a Boolean condition that evaluates to true or false. So x less than or equal to 5, it's going to ask a question. Is x less than or equal to 5? Okay. And then after that, we have our block of statements. Okay. Now, just like an if statement, your loop, if it's just a single line, it can just have a single line in there. If it's a block like this, you're going to want, or a couple statements, and usually it is a couple statements because you'll see we need to update our variable inside. Usually a loop has a couple statements. You'll need that block, an open and close curly bracket. Okay. So let's trace through this and see what happens. So we start off with x being 1, and then we have our condition. It says while x less than or equal to 5. So think about what that means in English, right? While x is less than or equal to 5. So we ask, is x less than or equal to 5? Currently x is 1. So yes, x is less than or equal to 5. That is true. So while x less than or equal to 5, we're going to run these 2 statements in here. I'm going to print off the value of x, which is 1, and then I'm going to increase x by 1. Okay, so x is now 2. And then because I reached the end of this, that's when I loop back up and I check the condition again. Okay, so the condition is checked once you reach the end here, and then you loop back up and check it again. So is x still less than or equal to 5? That is true. So we're going to run that set of statements again. So I'm going to print off x, which is currently 2, and then x increases by 1, so it becomes 3. Then I loop back up because I reached the end of that statement. I loop back up and I ask the question, is x less than or equal to 5? It is, because 3 is less than or equal to 5. I'm going to print it off. X increases by 1, it becomes 4. I loop back up. I check the condition again. 4 less than or equal to 5, that's true. I'm going to run this again. Print off 4, increase x by 1. I've reached the end, loop back up. Okay, you see what's happening here? Is x still less than or equal to 5? True, that is still true. So I'm going to run it again. I'm going to print off 5. X increases to 1. I check the loop again. Is x less than or equal to 5? No. Okay, now is the point where this statement has become false because right now x is 6. So what happens? The loop ends. Okay, it is done because 6 is not less than or equal to 5. That evaluated to false. And as soon as I check this condition and it evaluates to false, I skip and I continue on with my program. Okay. So that's a very important thing. Once it's false, you don't go through one more time. Okay. As soon as it's false, as soon as you check that condition, it's skipped and it continues on with the program. Okay. So all that got printed to the screen was 1, 2, 3, 4, 5. Okay. Even though x currently has the value of 6, so if I were to use x anywhere else in the program, x has the value of 6. But I only printed off 1 through 5 because that's all that was allowed to run with that while loop. Okay. So a couple different things happening here, a few different little things we got to remember if this is your first time learning about a loop. There's a lot of little things to kind of remember about this, but once you get the hang of it, you will be okay. All right, which is why I have a few more examples set up to help us practice this. If at any point you want to pause and trace through on your own and then check your answer, feel free to do that. But I'm going to go through what the answer is right now. Okay, here's another loop. I start off with 2 variables having values. Y is 3, Z is 0. And then I have my while statement. So I check that first while Y is less than 6. So is Y less than 6? It is, right? Y is 3 right now. 3 is less than 6. That is true. So when that is true, that means these 2 statements are going to run. So Z gets the value of Y times 2 added to it. So remember, with this compound operator here and the times, I do the Y times 2 first. So 3 times 2 is 6. And I add that to the current value of Z. So 6 plus 0 is 6. So Z becomes 6 with this line. And then Y increases by 1. Y increases to 4. So I've reached the end of my loop now. Okay, right? I've reached the bottom. And now is where I go back up and I check this condition again. So that condition does not get checked at throughout my loop. Okay, it gets checked at the beginning. And if it's true, everything inside runs. And then it doesn't get checked again until the very end, till I've reached the end. So even if at some point during the loop, Y becomes bigger than 6 and the condition becomes false, I still continue on with that loop until I've reached the end and I go back up and check it. Okay. That's when it gets checked again. So is Y still less than 6? That is true. So I'm going to run those 2 statements again. So this time, Y has the value of 4. Okay. 4 times 2 is 8. And then I add it to the current value of Z. And the current value of Z was 6. So 6 plus 8 is going to give me 14. Okay. So Z, this code up here, Z and Y, they don't reset at any point, right? We just keep manipulating those variables in my loop. So Z is now 14 and Y is going to increase by 1 and become 5. Okay. So I've reached the end of my loop and these are my 2 values of Y and Z. And I'm going to loop back up and check my condition again. Is Y less than 6? It still is. 5 is less than 6. So I'm going to run the code again. So in here, Y is currently 5. 5 times 2 is 10. I'm going to add 10 plus 14 because that was the current value of Z at that point. 10 plus 14 is 24. So Z becomes 24. Y increases to 6. And I've reached the end of my loop and I'm going to go back up and check it again. All right. Oh, my goodness. Is 6 less than 6? No. Okay. I am false. Okay. I've reached the false. And now what happens? Since this was false, I skip the block and I run the next line of code after my block, which prints off the value of Z, which is 24. Okay. So how many times did that loop run? That loop ran 1, 2, 3 times. Okay. We say we iterated through that loop 3 times before the condition became false. Okay. Now, when you iterate through a loop, you might iterate through 1 time or 3 times or 100 times, or sometimes even no times. I'm going to show you an example of that here in a moment. But your loop runs however many times it needs to until the condition becomes false. So while the condition is true, your loop is still going to run. Okay. Here's another example. Again, if you want to pause and try it, there's a few more things going on here. You can see that I have num1 and num2. I'll have my while loop, but inside I have a Boolean operator now. I have 2 conditions I'm going to check. And while both of those conditions I'm going to check, I need to make sure that they are both true in order to keep running. Why do I need to make sure that they're both true? Because of this and here, right? So remember, we learned about compound Boolean expressions before, in the lesson before this. And the and, as if this is true and this is true, the entire thing evaluates to true. So that means this while loop is only going to run while this statement is true and while this statement is true. The second one of those becomes false is when, or not the second, but when I go back up and check and one of those becomes false, my loop ends. Okay, so it's good when you're tracing through programs, especially as they start to become more complex like this, that you are looking at the code and trying to get an understanding of that before you start tracing, right? So you see how I haven't even traced anything yet, but I kind of understand the problem. I'm going to have 2 numbers, num1 and num2, and as long as those 2 statements are true, I'm going to keep running this loop, okay? So let's start a trace. I'm going to do a trace table. Num1 is 10, num2 starts off as 20. And I'm going to check this condition. Is num1 greater than or equal to 5? That's true. 10 is greater than or equal to 5. And num2 is 20. Is 20 greater than or equal to negative 2? Perfect. That is also true. So this statement is true and this statement is true. So I'm going to run my 3 lines of code right in here. Okay. So these 3 lines of code, the first prints off both values separated by a space, so 10 and 20. Then you can see that I'm going to update both of these values. Okay, I'm going to do a little bit of math here, right? So num2 is currently 20. I'm going to divide that by num1, which is currently 10, and then I'm going to add 7. Okay, so between division and addition, I do the division first, integer division, because those are both ints. That becomes 2 plus 7, and 2 plus 7 is 9. So this becomes 9. Num1 becomes 9. Okay. My next line, num2 minus num1 minus 3. Num2 is currently 20. Num1 is currently 9. And num3, 3. It's just 3. So I do this in order from left to right. So 20 minus 9 is 11. And then 11 minus 3 is 8. So num2 is going to be 8. Okay. Now I've reached the end, and then I'm going to go back up and check. Is num1 greater than or equal to 5? That's true. 9 is greater than or equal to 5. Is num2 greater than or equal to negative 2? That is also true. 8 is greater than or equal to negative 2. So I'm going to enter the loop again, and I'm going to run those 3 lines. Okay. I'm going to run prints off 9 and 8. And then I'm going to do this math again. Num2 is currently 8 divided by num1, which is 9, plus 7. What is 8 divided by 9 for integer division? That's 0. Okay, so I get 0 plus 7, which is just 7. So num1 is going to become just 7. All right, and then num2 is currently 8 minus 7 minus 3. So 8 minus 7 is 1. 1 minus 3 is negative 2. So num2 is going to become negative 2. Okay, so those are my 2 values. I've reached the end of my loop. Now I'm going to go back up and check my condition. Is num1 greater than or equal to 5? That is still true. And num2 greater than or equal to negative 2? That is also true. It's equal to, right? So both of those statements are true, or both of those little comparisons are true. So and true evaluates to true. So we enter again. And we'll do this again. We'll print off the 2 values, 7, negative 2. We're going to update these. Num2 is currently negative 2 divided by 7 plus 7. What's negative 2 divided by 7? Integer division. That's 0. All right. 0 plus 7 is just 7. Okay, so this really just stays 7. Okay, it updates to 7 again. And then here, num2 is -2 minus num1, which is 7 minus 3. -2 minus 7 is -9. -9 minus 3 is -12. Wait, yeah? -12. Oops, I put 11. Unless I messed that up. Nope. It should be -12, right? I'm not crazy. All right, -11, -12. I'll figure it out because I've reached the end of my loop. Okay, and my loop has ended. And now I'm going to go back up and check the condition again. Okay, so is num1 greater than or equal to 5? That's still true because 7 is greater than or equal to 5. But now I have -12 greater than or equal to -2. Okay, it says -11, but I'm pretty sure that's -12. Is that true? No. This is false. Okay, so this has become false. And this is false. That means, because I'm using the and, the entire expression evaluates to false. So since I've switched to false, I'm going to skip and continue on with my program, which means that I've reached the end here. This is my answer. This is what gets printed off to the screen. Okay? Yeah, isn't that exciting? That's loops. Okay, we're going to do, I think this is the last example before we do a little bit more discussion about these loops. But tracing through while loops is something that will be on the AP exam, and it just helps with your critical thinking, right? You have to understand how these loops work, even though it seems a little like, why would I need to do this, right? In the next lesson, we're going to talk about how we use these loops to help us start solving problems in our code. Okay, maybe you can already think of some examples of, man, it would have been nice to know this for another project I had earlier, right? So they're so helpful, but we have to know how they work at a foundational level here. So that's what these tracing problems are helping us do. So now I'm going to start off. Boolean myboo is true and counter is 0. Okay. Now, why do I have Boolean myboo equals true? Notice this while loop here. Okay. Now, just like the if statements, in the parentheses there, we need a Boolean expression. And sometimes that's a comparison, like counter less than or equal to 5. Sometimes it's using those Boolean operators like the ands and the ors. And sometimes it's just using a Boolean variable, like this example. So myboo is a Boolean variable that has the value of true. So what this is saying now, this is saying while myboo, which means while whatever myboo value is. And right now it's true. Okay, so this evaluates to true because myboo is true. And then we enter here. Okay, and what's going to happen in here? Let's start to put some English words to this. Counter increases by 1. And then we have an if statement in here. Okay, so we have a nested if inside my while loop here. And it says if counter mod 4 is equal to 0, that's when myboo becomes false. Okay, and then when myboo is false, then you can see that's when the loop is actually going to end. Okay, that's the only time myboo gets changed. Otherwise, myboo is always going to be true. Right? So let's trace through this. Myboo is currently true. I'm going to enter in counter increases by 1. I check 1 mod 4 is 1, not equal to 0. So the if statement is false and I skip the if statement, which means I've reached the end of my loop, and I go back up and I check my while loop again. While myboo is still true. Counter increases to 2. Counter 2 mod 4 is 2. Not equal to 0, so I skip my if statement. That never runs, and I go back up. Myboo is still true. Counter increases to 3. 3 mod 4 is 3, so that if statement gets skipped. Myboo is still true. Counter increases to 4. 4 mod 4 is equal to 0, because 4 divided by 4 has no remainder, right? So I finally reached a true statement in my if. Myboo becomes false. Myboo gets assigned the value false. So now when I go back up to check myboo again, myboo is false. So while false, well, since that condition is false, now this gets skipped and I go and I print off with the current value of counter, which is 4. Okay. So again, this code, as soon as this is false, when I go up to check, as soon as it's false, then I skip this and I continue on with my program, okay? All right. Let's talk a few of the finer points about these while loops now. Now, an infinite loop is a loop that continues to execute endlessly because the condition never becomes false. Okay, so here's an example of that. Okay, maybe you guys have kind of seen this as we've done some examples here. But if I have int x equals 1 and while x is less than 5, print I'm never stopping, right? If you paste that code into your IDE, what's going to happen? You're going to see an infinite loop happen. And all that's going to do, it's going to print I'm never stopping forever. Okay. Some IDEs can end the program eloquently. You can just click stop and it'll end it. Some IDEs, or if you're running through your console, it'll actually cause a crash to happen. Okay. Because you can see in there that x is always going to be less than 5. There's nothing inside that loop that changes the value of x. X is always going to be less than 5. So it's going to print forever, I am never stopping to the console since x never becomes greater than 5. Okay. So avoid infinite loops. We want to make sure the loop stops at some point. And infinite loops occur when the condition is always going to be true and the loop will never be exited. Okay. Now, this doesn't cause a syntax error. The compiler does not catch this. So if you paste that code I just had into the compiler, it'll compile fine. Right? And it'll run. It causes a runtime error. It'll cause your program to crash in some way. Okay. Again, depending on your IDE, some have it crash more eloquently than others. Okay. Another point to make, besides infinite loops, you have to be wary about entering loops. Your initial condition has to be true in order to even enter the loop. So if I had something like this, x equals 10, while x is greater than 0 and x is less than 5, is that going to be true? No, x is greater than 0, that's true. But x is not less than 5. So this whole expression evaluates to false because it's an and. And when you check that condition first and it's false, this loop just never runs. It's skipped and we keep going. Okay. Now, sometimes that's fine. Sometimes you might want that in your program depending on what you're trying to achieve, and it's okay. But there's other times where that code won't even run, but you want it to run. It's just that initial condition won't actually enter in the loop. So you want to make sure you're checking that logic as you go through. Okay, because this infinite loops and entering loops, exiting loops, all of that, those are logic errors if it doesn't behave like you want it to behave. In terms of syntax, they run fine, okay? But you'll run into a lot more logic errors with these loops, so you gotta watch out for them, okay? Now, another logic error is the scope of variables. So little backstory here, Java is what we call an efficient programming language because it cleans up as your program is running. So when it has unused variables, it cleans them up in an efficient way to save on space and memory while the program is running. We call this garbage collection as a cute, adorable term as the program is running. It gets rid of things that are no longer needed. And for us in this class, we don't really run into too much of an issue with that, except when it comes to scope of variables. When we declare a variable inside a loop or inside an if statement, we say its scope is just inside of that loop or the if statement. It doesn't exist outside of the loop or outside of that if statement and will therefore be garbage collected when the block is done executing. So this actually is true for anything declared inside a block, whether it's declared inside a class, declared inside a method, or declared inside a loop or an if statement. When you declare a variable inside a block, so inside those curly brackets, it only exists inside of those curly brackets, right? So usually that's fine. We haven't really had to talk about that too much before this because when we were making our methods, right, like our main method and we were running our program in our main method, we declared a variable and then we used it throughout our main method, and that was fine. Or when we had objects and we made our object and we had our instance variable. Remember how we declared instance variable at the top of our class? And then we were able to use it in any method, okay? That's because it was declared inside of the class block, so we could use it anywhere in our class. And with our main method, if we declare a variable in our main method, we can use it anywhere in our main method. Well, if we kind of narrow it down and declare a variable inside a loop or an if statement, we can only use it inside that loop or if statement. So this program causes an error when you run it. Okay, or excuse me, when you when it gets compiled, when it gets compiled, you have a compiler error here. And why? Right? Why? Because when you first look at it, you might not be clear. We have x equals 0, while x is greater than -1, int c equals 0, x equals scanner.nextInt. You're going to print off what that user entered, and c increases by 1. Okay, so the user is going to keep entering a number, keep entering x. You can see as long as the user enters a number that is greater than -1, so 0 or any number greater than that, any integer greater than that, the program is going to keep running. So if I enter a -2, that's when the loop ends. And then I go down here to print off you entered C numbers. Okay, so it counts how many times the loop runs, and then how many times the loop runs is going to be how many numbers that I've entered in my code, right? So logically, you're like, okay, that probably makes sense, right? You can see a couple logic errors actually though, because when you loop back up and that condition is still true, C gets reset to 0 here. Okay, so every time actually C gets set equal to 0 and resets to 0. So logically, it's not going to keep track of the numbers like you want it to. Okay, the other logic error is C right in here is going to be declared inside that while loop. Therefore, it only exists inside that while loop. So if you tried to use C outside of that loop, you are going to run into an error, because the program no longer has a variable called C. As soon as you exit this loop, anything that was declared inside that loop is garbage collected. Okay. Now, X, for example, X wasn't declared in that loop, right? X was used in the loop, just like some of the examples we've run before. The variables are used in the loop, that's okay, but it wasn't declared. So it's not garbage collected at the end of the loop. You can still use X anywhere in your program, but because C specifically was declared inside your loop, you're going to run into an issue. Okay? The way we fix that is to just move it out of the loop. Okay? So you can see here, I just put it outside of that while loop. And now not only does it logically make sense, but you won't run into that compiler error. Okay, because now C, it starts off as 0 outside of the while loop, but each time you loop through, it doesn't reset to 0. So logically, C is going to increase by 1 each time the loop runs, each time you enter in a number, but it's not going to end and still be just 1. Okay, so that's how you fix the code. Our last example, we're going to kind of get into writing our own loops here. In the next lesson, we'll get into working with algorithms even more. But here's an example of how we might start using loops here. So I have int loop and int value. Loop is some positive number, and value is some number between 1 and 9. So our instructions say to write a while loop that will iterate loop lines of random numbers between 1 and 9. The line of random numbers will end once the random number is equal to value. Okay? So if loop is 4 and value is 8. So this is an example of where we want to write code to work with different values that are going to be present. So loop in this example is 4, but loop might be 5, loop might be 6, it might be 7, it might be 100, right? Loop is just some positive number. Now, since loop is 4 means I'm going to run 4 times here. If loop was 5, loop is going to run 5 times. So I'd have 5 lines. Or if it's 100, I'm going to have 100 lines, right? So that's what's looping. And then it says value is 8. So the while loop is going to go, it's going to iterate for however many loop lines, and it's going to just print off random numbers until I reach the value 8. So you can see each line here reaches 8. And what happens? Well, as soon as 8 happens, I move to a new line and I keep printing off random numbers. Okay, so that's the pattern that's happening here. When you're given a task to write lines of code, you want to understand what pattern is happening, and you want to see, okay, where can I loop, right? Where's the loop happening here? And when you start writing this code, some of you might be able to say, okay, I know what this code is. Let me start writing it. What I found very helpful is to try to put this in words. Let me write out my steps here in words first, what we call pseudocode, right? And I'll write out the steps that I need, and then I'll translate that into code. So here's an example, right? If I'm working with this example, while loop is for, okay? While loop is for, generate a random number. I want to print that random number, and then I want to check to see if that random number is equal to value, okay? Because if it is, then I want to move to a new line and keep printing off random numbers, right? I want to move to a new line. And then my loop decreases by 1, meaning, okay, I've moved to a new line. I want to print 4 lines, right? And if I print 4 lines, as soon as I reach 8, I want to move to a new line. And if I move to a new line, that means, oh, check, I've done 1 line. So I want to loop decrease by 1, okay? So this is kind of my pseudocode here. And I've tabbed it over a little bit to help with the organization. Now, I say while loop is for, but loop is for is my example. So I want to make sure that I code that to work for any value that loop might be. And then in here I wrote if my random number is equal to value, right? Because value could be anything. And here value is 8, but value could be anything, okay? So I'm going to translate that into code. While my loop is greater than or equal to 1, okay, again, loop could be anything. In this example, it's 4, it could be 100. I want to generate a random number between 1 and 9. I want to print off that random number. That's that code. And then I want to run an if statement. I want to check if that value is equal to my random number, whatever value is. Not only do I want to decrease the loop by 1, I want to print off that new line. Okay. So see what I did here. Here I'm just printing random number, and then this is going to actually move the cursor to a new line here. Okay. Now I think in my pseudocode, I had these switched. You can see that you can switch those and the logic will stay the same. You can write those either way, but that's going to accomplish this task. Okay. Does that make sense? All right. Hopefully it does, because we have now reached the end of our video here on while loops. So introducing them, going through some tracing examples. In the next section of notes, we are going to be going over while loop algorithms. So looking a little bit more about how we use these while loops to accomplish tasks that are set out for us. So thank you guys so much for following along. If you have liked this video, please hit the like button and subscribe to my YouTube channel for more AP CSA content. And until then, I will see you in the next video. Thank you guys so much.